Welcome to the lesson on scales and rules. After completing this lesson, the learner will be able to compare and contrast various scales and tools, correctly record measurement readings from an English and metric scale, and formulate a plan explaining the measurement process for a scale. Scales and rules are the most basic measuring tools used for linear measurement. Scales and rules can have metric units, English units, or both. The four types of scales discussed in this lesson are machinist scale, tape rule, architect's scale, and engineer's scale. These are discussed in a bit more detail in the upcoming slides. The first tools this module will cover are scales and rules. The machinist's scale, or steel rule, is a 6-in ruler and is the most common and simplest linear measuring instrument found in a machine shop. On one of its edges, each inch is divided into 32 NDs, and on the other, each inch is divided into 64 ths. The tape rule, also known as a measuring tape, is a flexible tool that allows for measuring longer distances and curved surfaces, making it versatile for both construction and machining applications. Unlike rigid rulers, tape rules can be retracted and extended as needed, typically featuring both imperial, inches, and metric measurements, with common lengths ranging from 12 feet to 100 feet. The architect's scale is a triangular tool designed specifically for architectural drawings and blueprints, with multiple scales for converting measurements between full-size and reduced drawing sizes. Common scales include 1/4 inch equals 1 foot, 1/8 inch equals 1 foot, and 3/16 inch equals 1 foot. The engineer's scale is a specialized triangular ruler primarily used for technical drawings and civil engineering plans, featuring multiple sides with different measurement ratios, typically 10, 20, 30, 40, 50, and 60 parts to the inch. For example, in the 30 parts to the inch scale, 1 inch is divided into 30 parts, and each division represents 1/30th of an inch. So how do we read one of these scales or rules? The steps on this slide will help you master the skill of reading scales and rules. First, determine the measuring system to use. Second, determine the size of the scale or ruler to use. Third, examine the graduations on the scale or ruler you have selected. Fourth, align the graduations to take the measurement. Fifth, read the measurement. Lastly, if the measurement is fractional, report it in its lowest terms. Each of these steps will be discussed in detail in the next few slides. First, you must decide whether you will measure an object using the English system, inches, feet, or the metric system, centimeters, meters. Your choice of measuring system will depend on your type of work. For example, if you work at BMW, a European organization, you will need to understand and measure using the metric system. If you work at General Electric, an American-based company, you will need to understand and measure using the English system. If you are an aircraft maintenance technician, the measurements you take will be in the English system. And if you are an automotive technician, you will need to understand both the English and metric system and the relationship between the two, as many cars use both measuring systems, because their parts are manufactured around the world. Most common scales and rules have two measurements, one on each of their edges. As discussed earlier, a machinist's rule, for example, has two measurements in inches, but differing in the number of graduations per inch. Other scales and rules have one set of measurements in inches and the second in centimeters. The second step is to determine the size of the scale or rule to use. Common rules and scales can measure objects up to 12 inches or 30.5 centimeters. If you need to measure an object longer than that, you will need to use a yardstick for the English system, a meter stick for the metric system, or a tape rule that has both measuring systems. The third step is to examine the graduations on the scale or rule you have selected. There are different types of scales with different graduations and affiliated levels of precision. A graduation or mark is the fractional division between a unit of measurement, for example, 1 inch. When precise measurements are not required, it might be possible to report approximate readings, but it is usually preferable to avoid approximations and use scales with appropriate graduations. Knowing the graduations on the scale or rule will help you to quickly and correctly identify the measurement. Let's examine the graduations of a metric scale. The center graduation between two numbers, in this case 0 and 1, is half. The lines marked on this rule are 0, half, and 1. The next smallest graduation on a metric scale or rule is 1 millimeter. There are 10 millimeters in every centimeter. Each graduation between 0 and 1 represents 1 millimeter. On an English system scale, graduations begin with the largest divisions showing halves, 1/2, which are then subdivided into quarters, 1/4, 1/2, 3/4. The scale becomes more precise with eighth divisions, 1/8, 1/4, 3/8, 1/2, 5/8, 3/4, 7/8, and even finer with 16th divisions, 1/16 through 15/16. The most precise measurements on the scale show 30 seconds, where each small graduation mark represents 1/32 of an inch. Precision is also dependent on alignment of the work with graduations on the scale. When measuring an object, if the edge of the object measured aligns exactly with the graduation on the scale, the measurement is quite exact. This is not likely to happen for every measurement. When the edge of the work is not aligned with the graduation, you have to estimate the measurement. Your measurement will likely not be very accurate. Image A shows a rule in which the graduation is aligned with work, and B shows a rule in which the graduation is not aligned with work. Which measurement is more accurate? The correct answer is A. The fifth step is to read the measurement. When reading the measurement, you must first determine the type of scale you are utilizing. In this case, the scale is measured in centimeters. Therefore, all measurements made with this scale will have cm as its units. For object A, the object starts at 0 centimeters and ends at 3 centimeters. Therefore, object A measures 3 centimeters. Object B starts at 0 centimeters and is aligned with the half graduation between 4 and 5. Therefore, object upper B measures 4.5 cm or 4.5 centimeters. Object C also starts at 0 centimeters and the measurement lies between 6 and 7. The measurement is past the half graduation by 3 marks. Therefore, object C measures 6.8 centimeters. The objects in this slide do not start right at the 0 centimeter graduation. However, a precise measurement can still be taken. Object D starts at 2 centimeters and the end measurement reads 5.3 centimeters. In order to obtain the measurement for object D, subtract 2 centimeters from 5.3 centimeters. Therefore, object D measures 3.3 centimeters. Object E starts at the 0.5 centimeter graduation mark and the end measurement reads 6.5 centimeters. In order to obtain the measurement for object E, subtract 0.5 from 6.5 centimeters. Therefore, object E measures 6.0 centimeters. The sixth step is to report the measurement in its lowest terms if it is fractional. This step is only necessary when you're reporting measurements in fractional form. This will occur when using the English system, inches. Let's review the measurements for objects F through J. There are some fractions in the recorded measurement column that we have to investigate. Let's also review some math terms. The top number of a fraction is called a numerator, and the bottom number in a fraction is called a denominator. Factors are multiplied together to get another number. For example, 3 and 4 are factors of 12, but so are 6 and 2 and 1 and 12. If there exists a factor larger than 1 that is common between the numerator and denominator, then the fraction is not in lowest terms. This number is referred to as a common factor. In order to reduce a fraction to its lowest terms, we must find the greatest common factor. The greatest common factor refers to the largest common number that is a multiple of both the numerator and the denominator. Since the recorded measurement for object F does not have a fraction, we skip to object G with a recorded measurement of 2 3/4 inches. The factors of the numerator, 3, are 1 and 3, while the factors of the denominator, 4, are 1, 2, and 4. The greatest common factor, GCF, of 3 and 4 is 1, meaning the fraction is already in its lowest terms. Next, for object H, the measurement is 3 14/16 in. The factors of the numerator, 14, are 1, 2, 7, and 14, while the factors of the denominator, 16, are 1, 2, 4, 8, and 16. The GCF of 14 and 16 is 2. We divide both the numerator and denominator by 2, simplifying the fraction to 7/8, giving a revised measurement of 3 7/8 in. For object I, the recorded measurement is 16/8 in. The factors of the numerator, 6, are 1, 2, 3, and 6, while the factors of the denominator, 8, are 1, 2, 4, and 8. The GCF of 6 and 8 is 2, so we divide both by 2, simplifying the fraction to 3/4. The revised measurement for object I is 1 3/4 in. Lastly, for object J, the measurement is 31/4 in. The factors of the numerator, 1, are 1, and the factors of the denominator, 4, are 1, 2, and 4. The GCF of 1 and 4 is 1, so the fraction is already in its lowest terms. The final revised measurements should be reported. In summary, scales and rules are the most useful measuring tools for frequent and quick measurements. Accurate readings using a scale or rule depend not only on the machinist's perception, but also on the alignment of the graduation with the work. Reading a scale or rule is a valuable skill to have, and it is important you master this skill before you start working with other, more precise measuring instruments. Thank you.